Hello, I am Isaac, and today we shall be solving Jamb mathematics likely questions. You may be wondering, what are the questions Jamb sets? What are likely Jamb questions under statistics, under probability, under algebra? So this video is to answer your questions as to what Jamb says, Jamb likely questions, and detailed solution. This is the part 1. Part 2 of the video is on the way. Now, don't fail to subscribe to this channel for more amazing videos, and feel free to check out my other videos because you will find them very helpful. Without wasting time, let's get ready for Jamb. Now, take a look at this question. The first one says, convert 521 base 10 to a number in base 5. Convert 521 base 10 to a number in base 5. Number basis is a topic that is hot cake in mathematics. If you go for a mathematics exam, whether Jamb or WAEC, without questions under number basis, be surprised. So this is a very important question, and you will see it. In number basis, you may be asked to convert numbers from base 10 to other bases, or from other bases to base 10. You can also be asked to convert numbers between bases, from base 2 to base 5, from base 4 to base 7. Addition, subtraction, multiplication, and division of number bases is also very important. So these are under number system. If I ask you, what is 1 plus 1? You simply say 2. This is because you are already used to counting in base 10. There is another counting system where 1 plus 1 is not equals 10. For example, in base 2, 1 plus 1 is equals 1, 0. This is because so long you are counting in base 2, the highest number will be 1. You can't get to 2. And if you are counting in base 3, the highest number in base 3 is 2. 1, 0, 1, and 2. These are the numbers you find in base 3, which is 1, 2, 3. If you are counting in base 4, you have 0, 1, 2, 3. 3 is the maximum number you find while counting in base 4. So 1, 2, 3, 4. While base 10, our day-to-day counting, 9 is the maximum number you find. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Even 10. 10 is 1 and 0. This is how number bases work. For example, look at this question. Convert 521 base 10 to a number in base 5. Looking at the option, you see that the highest number is 4. So in base 5, you can't have 5 as a number. In base 2, you can't have 2 as a number. It deals with 0 and 1. Base 2 is also called binary, and base 10 is also called decimal or denary. Now, convert base 10 to a number in base 5. We are converting from base 10. How do you convert from base 10? How do you convert from base 10? This is what we do. Repeated division. 521. Since we are converting to base 5, you simply put 5 here. And this is the number we are converting in base 10. We do series of repeated division. If there's a remainder, we put it at the end. If there's no remainder, we put 0 at the end. That is remainder 0. 521 divided by 5 is equals 104. Remainder 1. 104. 5. 5 times 4 is 20. We put down a 0, 2. 5 times 0 is 0, plus the 2 we carried, 2. And 5 times 1 is 5. So 5 times 104 is 520. This means 521 divided by 5 is 104. Remainder 1. And 5 again, you keep dividing with 5. This is not LCM where you say which number can go. No. If we are converting 521 to base 4, we will divide through by 4 and keep the remainder aside. If we are converting to base 2, same thing. Base 6, the same thing. It's the same method. So any question that comes in your exam, always know what to do. So here we have 20 remainder 4. Now 5 again. 20 divided by 5 is 4. 4 times 5, 20. And there is no remainder. If you have 20 and you are sharing among 5 persons, they will happily take 4, 4, 4. And there is no remainder. Since there is no remainder, we simply say remainder 0. Now, 5 again. 4 divided by 5, 4 over 5. It won't work because 4 is smaller than 5. It won't work. So it will be 0 remainder 4. Since they can't divide, we simply put down 0 and remaining the 4. After division, immediately you get to 0 here. Stop. Then come here, draw arrow up. Start writing down the remainders from the last one to the first one. So you take 4, 0, 4, and 1. Then here you put base 5 because we just converted to base 5. What if you are asked, convert 4041 base 5 to a number in base 10. In this case, convert this to base 10. What do you do? To convert any number to base 10, no matter the base, no matter how big, no matter how long, it is the same procedure. Observe the number. This is 5. This is the number. And we are to convert to base 10. Simply look at the number. Come here. Put 0 at the top. Come here. 1. Come here. 2. Come here. 3. If it were more, you keep increasing the number. After doing this, pick the first one. 4 times the base 5. What is the power of 4? 3. Plus 0 times 5. 0 times 5. What is the power of 0? 2. Plus 4 times 5. 1 plus 1 times 5 raised to the power of 0. And look at this. Any meaningful number raised to the power of 0 is 1. If I say 3 raised to the power of 0, the answer is 1. 4 raised to the power of 0, the answer is 1. 1 million raised to the power of 0 is equals 1. Therefore, any meaningful number raised to the power of 0 is 1. This makes here to be plus 1 times 1 because 5 raised to the power of 0 is 1. Here is 4 times 5, that is 20, plus 5 raised to the power of 2 is 25. But 0 times any meaningful number, you get 0. So this is automatically 0 because of times 0. 0 plus 5 raised to the power of 3 is 5 times 5 times 5. 5 times 5 is 25. 25 times 5, 25, carry 2. 5 times 2, 10, plus 2, 12, 125. So 125 times 4, you simply say 125, then 4 here, and times. 4 times 5 is 20. So we put down 0, carry 2. 4 times 2 is 8, plus the 2 we carried, 10. We put down another 0, carry 1. 4 times 1 is 4, plus the 1 we carried, 5. This means 4 times 5 raised to the power of 3 is 500. 500 plus 0 plus 20 plus 1 times 1 is 1. 1. This will give you 500 plus 0, 500 plus 20, 520 plus 1, 521 base 10. You see, this further shows that our answer is correct. If you convert the number from base 10 to another number, immediately you convert back to base 10, you get the same answer. Nothing changes. So this is how to convert from base 10 to other bases. from other bases to base 10. If you are converting from base 2 to base 10, let's say 1 0 1 1 1 base 2 to base 10, you simply say 0 1 2 3 4. 1 times 2 raised to the power of 4 plus 0 times 2 raised to the power of 3, just the way we solve this. What if you are converting from base 3 to 5? To convert from a number in base 3 to a number in base 5, what you do is this. First of all, convert this base 3 to base 10. After converting the number in base 3 to base 10 by using this method, therefore that answer you get in base 10, convert it to base 5 by using repeated division. If I say 1 1 1 1 base 2 times 1 0 1 1 base 2, or plus, or divide, or minus, the easiest way or the most accurate way to answer this type of question is simply convert this first one to base 10, convert this one to base 10, multiply, subtract, add, or divide. After getting your answer in base 10, convert from that base 10 back to the required base, in this case base 2. With that, your answer will be very, very correct. Now take a look at the next question. This is an equation. Take note that there is a big difference between equation and expression. If I tell you 2s plus 3, this is an expression. Why expression? Because there is no equality sign, no equal to sign. But so long there is an equal to sign, it means that this is an equation. If you solve for s correctly and you substitute that value of s here, everything here will go down to 1. Now let's solve. Given this, there are different ways we can start. We can choose to, different ways. You can choose to do something like this. 1 over 1. Let this one be 1 over 1. Then you cross multiply. Since this is the same thing as this, you simply say 2 minus s is equals 3 times 1, that is 3. Everything here times 1 is the same. After cross multiplying, you open up the bracket by using 2 to multiply each of the numbers inside the bracket, or each of the values. 2 times 2 is 4 minus 2 times s, 2s is equals 3. Now look at this. 2 times s is equals 2s, but 2 plus s is equals 2 plus s. You can't add a number and letter. 2 minus s is equals 2 minus s. You can't subtract a number and letter. 2 divided by s is equals 2 divided by s. You can't divide a number and letter. Only multiplication works. Now that you have this, you collect like terms. There is s here, but this is a number without s, and there is no s here. So we take this to the other side. It is negative. As it crosses the equality sign, it becomes positive. And 3 here is positive. As it crosses to meet 4, it becomes negative. That is minus. Making us to have 4 minus 3 is equals 2s. 4 minus 3 is 1. 1 is equals 2s. S is equals 1 over 2. So let's look at this one, other method. Another method is 2 over 3 times 2, that is 4 over 3, minus 2 over 3 times s, that's 2s over 3 is equals 1. 4 over 3 minus 1 is equals 2s over 3. 4 over 3 minus 1, here is the same thing as over 1. The LCM is 3. 3 divided by 3 is 1. 1 times 4 is 4. Minus 3 divided by 1 is 3. 3 times 1, 3. This is equals 2s over 3. 4 minus 3 is 1. 1 over 3 is equals 2s over 3. We still cross multiply. 3 is equals 6s. Dividing both sides by 6, s is equals 1 over 2. So the value of s is 1 over 2. We can actually confirm if it is true. Let's see. If we put 1 over 2 here, it becomes 2 over 3, 2 minus 1 over 2. 2 over 3 times 2 is 4 over 3 minus 2 over 3 times 1 minus 1 over 2 is 2 times 1 is 2 over 3 times 2 is 6. So this is 4 over 3 minus 2 over 6. The LCM is 6. 6 divided by 3 is 2. 2 times 4 is 8 minus 6 divided by 6 is 1. 1 times 2 is 2. This is 8 minus 2 is 6, right? 6 over 6. This is equals 1. You see? So getting the value of s as 1 over 2 and putting 1 over 2 here, everything here becomes 1. This means 1 is equals 1. Isn't it? 1 is 1. Find the sum of 20th terms in an arithmetic progression whose first term is 7 and last term is 107. Arithmetic and geometric progression are hotcake topics in Jamb, popularly known as AP and GP. Now, arithmetic progression is a progression in which the second term minus first term is the same thing as the third term minus second term is the same thing as the fourth term minus third term. If I have 1, 3, 5, 7, and 9, this is the first term, second, third, fourth, and fifth term. Let's say to be continued. The second term minus the first term is 3 minus 1, and that is 2. The third minus second term is 5 minus 3, that is 2. The fourth term minus the third term is 7 minus 5, and that is equals 2. You see? So subtracting each of the successive terms, you get a constant answer. And this constant answer is referred to as common difference. So we refer to this as arithmetic progression, AP. We have other progression like 2, 4, 8, 16, and so on. Given this type of sequence, this is the first term, this is second, this is third, and this is the fourth. This minus this, 4 minus 2 is 2. But 8 minus 4 is not 2. So subtracting second term minus first term is not equals third term minus second term, and it's not equals fourth term minus third term, and so on. So this is obviously not an AP. Now let's do something. Second term divided by first term, that is 4 divided by 2 is equals 2. 8 divided by 4 is equals 2. 16 divided by 8 is equals 2. This means the second term over first term is equals the third term over second term is the same thing as the fourth term over third term, and so on. In this case, we say the common ratio is 2. Common ratio. This is a geometric progression. So when it meets this condition, you subtract, you get the same answer, or you get common difference. That is arithmetic progression. When you divide, and you get a constant answer, which is called the common ratio, we refer to this as geometric progression. Now, to answer many questions, or as many questions as possible under arithmetic and geometric progression, you need to know some formulas and ability to solve equation. With these two skills, you are good to go. Now, with these formulas, you'll be able to solve as many questions as possible under AP and GP. Now the first formula here is Tn. It means end term. What is end term? If I give you something like this, 1, 3, 5, 7, and so on. The first term is the first number. So we refer to it as A. A is equals 1. That is the first number here. What if you are asked for the 10th term? Because this is first, second, third, fourth, to be continuous. They didn't give us the other term. If I say look for the 10th term, you already know the pattern. The difference is 2, 7, 8, 9. Okay, 9 will be here, 10, 11. If I now say the 50th term, you cannot be writing up to 50. So you need a formula to look for the term. It means the number. Tn, if n is 5, it means look for the 5th number. That is what term means. So in this case, if I say look for 5th term, look, we already have 5th term, 10th term. It means what is the 10th number? You simply bring this formula, Tn is equals A plus n minus 1d. In this case, n is 10. N is the number we are looking for. A is the first term and D is the common difference. Like I told you, the second term minus first term is equals to third minus second. So it's a constant number. That is the common difference. D is equals 2. So 10th term, T10 is equals A, 1 plus N, 10 minus 1, D is 2. We have 1 plus 9 times 2 is equals 1 plus 18, which is equals 19. So if you try to keep counting, the 10th term will be equals 19. This is what this formula is used for. Now, Sn is sum of 10. For example, if I give you this and I say, look for the sum of the first 50 terms, it means the first 50 number, add them together. If you are doing that manually, it will take you a lot of time, sometimes years. Because if I say find the sum of the first 1 million terms, it may take you up to like 6 years or more to answer. You simply use this formula. What is this? If I say sum of the first 50 terms, here will be 50, here will be 50. Here A is first term, N is 50, and D is the common difference, depending on the arithmetic progression you are given. Now, this is also sum of terms. But in this case, if you are given the last term, looking at this question, we are told that find the sum of the 20th terms of an arithmetic progression, AP. Add the 20th term. We are given the first term, A, to be 7, and last term, L, to be 117. This means to look for that sum, this formula will work perfectly. Because sum of the first 20th term, S20 is equals, N is 20. 20 over 2. First term is 7. 7 plus the last term, 117. You see? So this is the answer to this question. You simply substitute into this formula. That will give you 20 over 2 is 10. 117, 7. 7 plus 7 is 14. Carry 1, 2, 1. 1, 2, 4. Times 10 is 1, 2, 4, 0. So this is the sum of the first 20th term. 1, 2, 4, 0. So life becomes very, very easy. Now, similarly for GP, this is the sum for infinity. You can be asked, find the sum of infinity of the GP, sum to infinity. So long you have the first term and the common ratio. Arrow is the common ratio. What is common ratio? When I was giving you example, I said in GP, it is you say second term divided by the first term, third term divided by the second term, fourth term divided by the third term. You keep getting the same answer. That is what we refer to as the common ratio. In this case, arrow represents the common ratio. If I say first term is 5, common ratio is so number, it's easy for you to find the sum to infinity. Very easy and straightforward. You may not need to even write anything down. This is for the nth term of GP. If you are given a GP, something like this, 2, 4, 8, 16, and so on. This is a GP because this divided by this is the same thing as this divided by this, and so on. If I say, okay, find the 50th term, since the nth term is equals a arrow n minus 1, the fifth term or the fifth number is simply when n is 5. That would be t5 is equals a arrow 5 minus 1. That is t5 is equals a arrow raised to the power of 4. If you are given the first term, we are given a 2. A is equals 2. The common ratio is what you get when you divide the second by the first term. That is 2. Or the third by the second term, 2. Arrow is equals 2. A2, arrow 2. The fifth term is simply 2 times 2 raised to the power of 4. This is 2 times 2 raised to the power of 4 is 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 2 times 16, that is equals 32. So 1, 2, 3, 4. Here will be 32. That is the fifth number. Now Sn is sum of terms, just like we did here. If I say sum of the first 20th term of a GP, you need the common ratio raised to the power of 20, and here is the common ratio, here is the first term. Just substitute and you are happy. Then this is when the common ratio is greater than 1, you use this formula. When the common ratio is lesser than 1, you use this formula for sum of GP. Now let's answer the other questions here. The second question says, find the sum of the first 20th terms of the linear sequence. Linear sequence, this is simply AP, because 5 minus 1 is 4, 9 minus 5 is 4, 13 minus 9 is 4. So it has common difference. 5 divided by 1 is 5, 9 divided by 5 is not 5. It is obviously not a GP, it is an AP. Now that we have the common difference, A is 1, that is the first number, or you say the first term. The sum of the first 20th term is simply substituting into this formula. If we are given the last term, we would have used this formula like we used in the first question. But this time around, we don't have the last term. Therefore, the sum of the first 20th term is S20 is equals N20 over 2. 2A. A is 1. That is 2 times 1. Plus N is 20. That's the sum of the first 20th term we are looking for. Minus 1. D is the common difference. That is 4 times 4. So sum of the first 20th term is equals 10, 2 plus 19 times 4. This is the answer. You solve, get your final answer, you pick the correct option. And the next question says, the second term of an exponential sequence is 35, and the fourth term is 875. Find the first term. How do you solve question like this? Exponential sequence is simply GP. That is another word for exponential sequence. And the nth term of a GP is a arrow n minus 1. We are told that the second term, like T2 is equals 35, and the fourth term is 875. T4 is equals 875. What does this mean? T2 is 35, and what is T2? It is when n is equals 2. So when n is 2, T2 is equals a arrow n 2 minus 1. T2 is equals a arrow raised to the power of 1. And we are told that T2 is equals 35. This means 35 is equals a arrow, equation 1. Then T4. T4 is fourth term when n is equals 4. So T4 is equals a arrow, n is 4 minus 1. T4 is equals a arrow raised to the power of 3. And T4 is equals 875. This means this is the same thing as 875 is equals a arrow raised to the power of 3, equation 2. So we have this equation, we have this other equation. we are looking for the first term, which is a. To get a, we solve the equations simultaneously, this and this. From equation 1, a is simply 35 over r. If a is 35 over r, substituting into equation 2, 875 is equals 35 over r, which is a times r raised to the power of 3. Here cancels one r to give you r raised to the power of 2. This means 875 is equals 35 r squared. Dividing both sides by 35, r squared is equals 875 over 35. R is equals the square root of 875 over 35. Remember, to remove square, we look for square roots of both sides. While to remove cube, we look for the cube root of both sides. R is equals 5. Since R is equals 5, but A is 35 over R, which is simply 35 over 5, and that is equals 7. So the first term is 7, and the common ratio is equals 5. If 5, S, Y, and 40 are geometric progression, that is GP, find S and Y. What does this mean? Find the second and the third term. The first term is A is equals 5. The fourth term is 40. Fourth term is T4 is equals A arrow 4 minus 1. T4 is equals A arrow 3. Since T4 is 40, 40 is simply A arrow raised to the power of 3. And A is 5, which means 40 is equals 5 arrow cube. 40 over 5 is equals arrow cube. Arrow is equals cube root of 40 over 5. Arrow is equals cube root of 8, and that is 2. 2 times 2, 4 times 2, 8. Arrow is equals 2. If arrow is equals 2, what we are asked for S and Y, the common ratio is found to be 2. S is simply the second term, that is T2 is equals A arrow 2 minus 1. T2 is equals A arrow, and that is first term times common ratio, 10. So this is 10. The third term is T3, that is A arrow n minus 1. That is A arrow 3 minus 1. That is A arrow raised to the power of 2, which is 5 times 2 raised to the power of 2. 5 times 4, that is 20. So this is 20. Look at this question. It says, in the diagram above, what is the value of AB? This is simply a triangle. A triangle is any shape with 3 sides. We have different types of triangle. If you are given something like this is a right-angled triangle because one of the angles is equals 90 degrees. And to solve right-angled triangle, we apply Pythagoras theorem. Pythagoras theorem states that h square, which is hypotenuse, is equals opposite square plus adjacent square. And we know the trig ratios are SO, K, TOA. Sin theta is equals opposite over hypotenuse. Sin opposite hypotenuse. And cos theta is equals adjacent A over hypotenuse H. Tan theta is equals OA opposite over adjacent. The longest part of a right angled triangle is the hypotenuse, while this part is the adjacent. There is the opposite. And this is Pythagoras theorem. The square of the hypotenuse is equals the square of the opposite plus the square of the adjacent. The Pythagoras theorem applies only to a right-angled triangle. And like I said, right-angled triangle is a triangle in which one of the angles is 90 degrees or is a right angle. We have another type of triangle like this. In this type of triangle, it shows that all the sides are equal. And if all the sides are equal, it means all the angles are equal. And it is simply 60 degrees here, 60 degrees here, and 60 degrees here. The sum of angles in a triangle is equals 180 degrees. So a triangle which all the angles and all the sides are equal is referred to as equilateral triangle. Now there is another type of triangle in which two sides and two angles are equal. Looking straight, you see this. Two of the angles are equal. And this line is telling you that this side AB is the same thing as side AC. These two sides are equal, just like these two angles are equal. A triangle where two of the angles and two sides are equal is referred to as isosceles triangle. This is an isosceles triangle. I told you that Pythagoras theorem only applies to right-angled triangle. While for isosceles triangle, we use sine rule or cosine rule. To solve this, we say that this is the angle, this is another angle, this is another angle. This is angle A and this is side A. We can say that sine A over A is equals sine B over B, meaning sine 120 degrees over 9 is equals sine 30 degrees all over AC. So this is AB. So that is sine 30 degrees equals sine 30 degrees all over AB. So sine 120 degrees over 9 is equals sine 30 degrees all over AC. Making AB subject formula, AB, which is sides, is equals sine 30 degrees times 9 all over sine 120 degrees. This is equals 3√3 centimeter. So AC is 3√3 centimeter and AB is 3√3 centimeter. So the correct option is 3√3 centimeter. And based on the size of angles, we have acute angle, obtuse angle, and reflex angle. Acute angle is an angle which is less than 90 degrees. Obtuse is more than 90 degrees but lesser than 180 degrees. While reflex angle is more than 100 degrees but lesser than 360 degrees. This is under inequality. It says 3s plus 5 is greater than 0. To solve inequality questions, solve them like equation, except that when you divide both sides by a negative number or you multiply both sides by a negative number, the sign changes. And also note that if 2 is lesser than 3, 3 is greater than 2. Unlike equation where if 2 is equals s, s is also equals 2. For inequality, if 2 is lesser than s, s is greater than 2. To solve this, we open up the brackets. This will give you 3s squared plus 15s is greater than 0. 3s is greater than 0 or s plus 5 is greater than 0. 5 years ago, the age of a mother is 5 years lesser than thrice her son's age. In 5 years' time, she will be 35 years older than her son. Find her son's present age. This is a word problem question. It requires analysis. It requires thinking. Look at it. We are told of a mother and a son. let the mother be M and let the son be S. Now, 5 years ago. What is 5 years ago? 5 years ago is when the mother's age is M minus 5 and the son is S minus 5. Because if you are 10 years old now, 5 years ago, you are simply 10 minus 5. 3 years ago, you are simply 10 minus 3. So 5 years ago, this is the age of the mother and this is the age of the son. And it says, this is 5 years ago for the mother and this is 5 years ago for the son. It says the age of the mother is 5 years lesser than thrice her son's age. 5 years lesser than thrice her son's age, which is thrice her son's age minus 5. That was the age of the mother 5 years ago. So the age of the mother, M minus 5, is equals 3 times the son's age, S minus 5. After multiplying by 3, we remove 5. That's the meaning of 5 years lesser than thrice her son's age. This means M minus 5 is equals 3S minus 15 minus 5. M minus 5 is equals, in 5 years time, she will be 35 years older than her son. Find her son's present age. In 5 years time, it's simply mother plus 5 and son plus 5. But this question says, in 5 years time, the mother, M plus 5, is 35 older than the son, which is S plus 5 plus 35. Which means M plus 5 is equals S plus 40. M minus S is equals 40 minus 5. M minus S is equals 35. Now we have equation 2, equation 1. Equation 1 says that M minus 3S is equals 15. Equation 2 says that M minus S is equals 35. From M minus S is equals 35, M is equals 35 plus S, equation 3, equation 2, equation 1. If M is 35 plus S, putting this in equation 1, instead of M, we put 35 plus S. Therefore, 35 plus S minus 3S is equals minus 15. S minus 3S is minus 2S. Minus 2S is equals minus 15 minus 35. Minus 2S is equals minus 15 minus, that is minus 50. So S is equals 25. So her son's age is 25. Putting this value in equation 3, mother will simply be 35 plus 25. 35, 25. 0. Mother is simply 60 years old, while the son is 25 years old. That is it. Let's see the next set of questions. Let us end Jamb likely questions part 1 with this set of questions. Don't forget, part 2 is there. I'll share a link to part 2 of this class. We are covering all the topics, questions, and everything that are likely to come out in your next Jamb. Now let's be fast about this. The first question says, find 2a if a is equals this. This is a 2 by 2 matrix, and this is under scalar multiplication. Scalar multiplication. What does it mean? This is the verb a. We are using a single number to multiply a matrix. We refer to that as scalar multiplication. Since a is this and 2 times a, that will simply be 2, 2, 5, 4, 3. This is simply using 2 to multiply each of the numbers in the matrix. This is a 2 by 2 matrix. It has 2 rows and 2 columns. This gives us 4, 10, 8, and 6. What if we are asked to look for something like this? That means the determinant of a 2 by 2 matrix is simply this times this minus this times this. That is 3 times 2, 6 minus 20. That is minus 14. That is the determinant. But in this case, we are asked to multiply. And the next question says, if you borrow 500 naira at 10% simple interest for 5 years, the interest you owe will be we have money you borrow, which is the principal. We have a rate, which is in percentage. We have time, which is 5 years. This question simply means find the simple interest. And simple interest is SI is equals principal times rate times time all over 100. And that is principal 500 times rate, which is 10. Don't add the percent because we're already dividing by 100 to cover up for the percentage. Time is 5 years times 5 all over 100. So these two zeros simply cancels these two. We have 5 times 5, 25 times 10. That should be 250. Also, that is the simple interest. And in the next question, we are asked to solve 3 minus 2 divided by 4 over 5 plus 1 over 2. Something is important in this question. We have addition and subtraction mixed with division. Anytime addition or subtraction is mixed with multiplication or division, you don't go ahead to say 3 minus 2. No, we use BODMAS. BODMAS shows us the order of operation, which means solve the bracket first. In this case, we don't have a bracket. What should we solve next? It is off. In some question, you'll be told 2 over 3 of 50. Off is multiplication. 2 over 3 of 50 simply means 2 over 3 times 50. This is 100 over 3. There is no off. Next, division. There is division, which is this. So the division is affecting this, which means in this question, we will have to take care of these two, while these other ones remain the same. Dealing with division, the easiest way is to convert it to multiplication. How do we do that? Immediately you change this to multiplication. Here invert, it becomes 5 over 4. So changing division to multiplication, the next number after it inverts. Instead of 4 over 5, it becomes 5 over 4. Now, what next? Multiplication. BODMAS says, after division, solve multiplication. So multiplication is here and here. This is here. Minus 2 times 5 is minus 10. And the next question says, simplify. So we are given 27, 1 raised to the power 1 over 3 times 2. This is an indices question. To simplify this, or to solve the indices, we know that 27 is the same thing as 3 over 3. Meaning we have 3 over 3 raised to the power 1 over 3 raised to the power of 2. 3 raised to the power of 3 raised to the power of 3. Indices says that we can multiply them, which means we can say 3 raised to the power of 3 times 1 over 3 squared, which is 3 times 1 is 3. 3 over 3 is 1. 3 raised to the power of 1 is 3. So this is something as 3 squared. And that is 3 times 3. This is 9. That is what indices says. And the next question is under set. We are given the universal set U. And we are given subsets M and N. These are the members of N. These are the members of M, and these are the members of the universal set. It says find M prime union N. M prime is simply what is in M that is not, what is in the universal set that is not in M, that is M prime. So look at M, look at universal set. What is here that is not here? F, the members are F, G, there is no G here, G, H, there is H here, so it's not, P, there is no P here, Q, there is Q, so we don't write it, R, no R, there is S, so this is M prime, the elements of universal sets not present in M, and N prime is simply what is present in the universal set that is not present in N, which is E, F, G, H, P, Q, R, S, and S. So this is M prime and this is N prime. The question says M union N. Union means merge the two sets. That is union. M prime union N prime is simply E, like merge them, then arrange them in ascending order. E, F, there is F here, there is F here. You write just one, don't repeat. We have G, H, J, P, Q, R, S in order. This is M prime union N prime. What if they had said M prime intersection N prime? It will simply be what M prime and N prime have in common. That is intersection. And this will simply be they have F in common. If this is G, if this is G, they have G in common. Arrow, no. This should be the only two things they have in common. That is intersection. And the next question is under change of subject formula. We are asked to make W subject formula. S is already the subject formula. The first thing we do is remove this square root. To remove square root, we square both sides. That means S squared is equals 6 over V minus W over 2. We've done that. Then S squared minus 6 over V is equals minus W over 2. Or we would have just said W over 2 is equals S squared is equals 6 over V minus S squared. W is equals 2 bracket 6 over V minus S squared. You can either leave it like this or say W is equals 12 over V minus 2S squared. That is making W the subject formula. And this question says, find the area of a circle. Okay, the area of a circle is 154 centimeters squared. Find its circumference. Area is equals pi r squared. Circumference is equals 2 pi r. From area is 154, it means 154 is equals pi r squared. And pi is 22 over 7. So 154 times 7 over 22 square root is equals r. So from here you get the radius. After getting the radius, substitute it into the value of circumference. So circumference is equals 2 times 22 over 7 times the value of radius. So this is 7. The arrow is equals 7. And look at this. If S is inversely proportional to the cube root of Y, it means S is cube root of Y. Then we introduce a constant because we don't solve with proportionality sign. So S is therefore is equals K over cube root of Y. Then K is equals S times cube root of Y. Now Y is 8. Cube root of Y is 2. So K is simply S 1 times 2. That is 2. Constant is 2. So S is equals 2 over cube root of Y. Find Y when S is equals 3. So you simply put Y here. So cube root of Y is equals 2 over S 3. So to remove cube root, we look for the cube of both sides. So Y becomes 2 over 3 over 3 over 3. And this says this. The polygon has 5 angles. This means it is a pentagon. And the sum of interior angle of a polygon is equals n minus 2 times 180. Sum of interior angles. Since we are talking about pentagon, n is 5. So this means the sum of the interior angles is 5 minus 2. N is the number of sides times 180. That is 180, which is equals 540. This implies that the sum of the angles s plus 2s plus 3s plus 4s plus 5s is equals 540. So add all the values of s, equate it to 540, then you get your answer. That is 5 plus 4, 9, 10, 15. Okay, 15s is equals 540. S is equals 540 over 15. You get your answer. And the final one, if the angle of a quadrilateral are this, and this, and this, find y. A quadrilateral is a four-sided shape. This is degrees. Any shape with 4 sides is a quadrilateral, like square, rectangle, this guy, and so on. And the sum of angle in a quadrilateral is 360 degrees. How do you solve this question? Add everything here, this plus this plus this plus this is equals 360 degrees. So solve, make y subject formula, and get your final answer. So that is it on these questions. I hope you found this class very, very helpful. Don't forget, likely Jamb Mathematics questions, part 1. Part 2 will be shared below. Thank you. Don't forget to subscribe.